Hey Forrest, what you doing?
Hey Emily, I'm just trying to figure out what I'm doing this winter break.
Cool.
Yeah.
That's a nice bridge.
Yeah, I found some place in Jersey. This is a truss bridge.
Wow, that reminds me of a problem we did in statics, chapter 6, problem 35. Let's take a look at it.
And this is the problem we're going to be working on. We're going to use the method of joints to solve for the force in members EI and JI.
Alright, so after we draw the diagram, we're going to work on the support reactions. So our first one is sigma Fx equals 0. And that's the easiest one to start with because there's only one direction, one force in the x direction, which is this AX. So AX equals 0, it's the only one. Moving on to the moment around A, you do this to find GY. So we have this negative 4,000 times 9 feet, because that's in a negative direction from what I put as the positive direction. The distance is at 9 feet. Then you move over to the 8,000, that's also negative direction, times its distance of 18 feet. Then we're going to go to this last external force, which is the 5,000 pounds, again in that negative direction, and this time the distance is 45 feet. And the last one is GY, and that's in the positive direction, and then that's 54 feet the distance. So when you solve this, you get GY equals 7,500 pounds. Moving on to FY, all you have here is the GY pointing up, and then these external forces pointing down, and then your only unknown is AY. So you plug in those, you have GY minus 8,000, minus 4,000, minus 5,000, plus the AY equals 0. The GY is 7,500, so if you solve for AY, you get 9,500 pounds. So after the support reactions, we're going to start looking at the joints. This is just one method of doing this. We're going to talk about the other method after, which is the method of sections. But just to start off, the method of joints, we're going to look at just joint G first. So looking in the Y direction, you have GY, which is the 7,500 pounds, minus its HG times 4 over 5. And I'll explain, we got that 4 over 5 because the distance here was 12 feet, and the horizontal distance was 9 feet, which is basically a 3, 4, 5 triangle. So instead of using 9, 12, 15, we're just going to use 3, 4, 5. So back to here, you set that equals 0. When you solve for it, HG comes out to 9,375 pounds. You then use that number to do sigma Fx to find FG. So in the x direction, HG times this horizontal 3 over 5, plus the FG, because they're both in the same direction, equals 0. And when you do, you plug in this 9,375 for HG, and FG comes out to negative 5,625 pounds, which means it's 5,625 pounds, but actually in that direction, which means it's a compression force, as opposed to this HG, which is pulling down, which is a tension force. So we're going to move on to joint H after, just looking at the main diagram if you want to. We're starting at G, then to H. So just redrawing what's at H, we have this HG going in that diagonal direction, FH, and HI. So looking at sigma Fx first, set that equal to 0. You get HG times that 3 over 5, that same horizontal distance, which is 3 over 5. Minus, because it's in the opposite direction, HI equals 0. When you plug in the 9,375 here, you get HI equals 5,625. Again, that number is positive, which means that it is in this direction, and it's a tension force. So moving on to the Fy, sigma Fy equals 0. So this one you have HG times this 4 over 5, plus, same direction, FH equals 0. Plug in the HG, and then you get FH equals negative 7,500 pounds. This means that the FH is really in a downwards direction, and it's a compression force. So after joint H, we're going to move on to joint F, and this is the diagram of what joint F looks like. We have FG pointing in this direction, but it's a negative 5,625 pounds, which means it's really just 5,625 pounds pointing in this direction, which is a compression force there. Then we have FH coming down, but that's also a negative, so it's negative 7,500 pounds, which means it's really pointing upwards. so that's also compression force. Then we have this negative 5,000 pounds pointing downwards, which is an external force. You have the force EF coming in this direction, and then you have Fi coming down this diagonal direction. So to solve for Fi, you do sigma Fy. You have this negative, because it's downwards, but then it's also a negative direction. So negative 7,500 minus the 5,000. And then also in that same direction, minus Fi times again that 4/5. That equals 0. Solve for Fi, you get 3,125 pounds. Moving on to the x direction. This is our negative direction, so we have negative 3,125, which is this Fi, times the 3/5. Then minus is also negative direction, EF. And then it's this plus this force, which is a negative number, so it's plus the negative 5,625 equals 0. And that EF comes out to negative 7,500 pounds. Then we're going to move on to our last joint, joint I. And here we have IF working upwards, IH is coming across horizontally, EI upwards, and then JI horizontally in the opposite direction. So we're going to start off with our sigma Fy equals 0. You have EI plus IF, again this 4/5, equals 0. And you get your answer of EI is negative 2,500 pounds. So that negative number means that EI is really compression force pointing down. So that's our first number that we were looking for, that EI. Then we move on to our sigma Fx equals 0. What we have is this JI in the negative direction, plus the IH is in the positive direction, plus the IF times, again, this 3/5 to make it horizontal. And that's in the positive direction, equals 0. When you solve for JI, you get 7,500 pounds. That's a positive number, which means that JI is working in this direction, and it is a tension force. So that's how we solve this problem using the method of joints. It's a little long, so now we're going to check out the actual easier way to do it.
And now we're going to analyze this problem using the method of sections. We're going to cut the truss from point Z to point Z using this line. And we're also going to need to use our support reactions again, so remember that Gy is equal to 7,500 pounds. Alright, so now we're going to use this drawing to help analyze the method of sections. What we're going to do is initially start with the sigma Fy, because the only forces we have here are external force, Gy, the force at Fb. So we can use that, and knowing what our Gy force is, we can solve for force Ei. Now it's going to come out to be a negative number, which just implies that force Ei is a compression force. And then we can take the moment about point E, which isn't included in our sections, but we take it so that we can ignore Ei and have our two known forces, 5,000 and Gy, leaving Fgi as our only variable. Once we do that, we'll set up this equation, and once it's solved, we'll get 7,500 pounds as the force in Ji. The method of sections is obviously a much faster way of solving these problems, especially with larger bridges and trusses. The method of sections can help save a lot of time. However, if you're working with a much smaller bridge or with a small number of forces or joints, then the method of joints can be a much faster way.